Hello, I'm Robert Clayton. I'm just going to show you my blockchain project. This was week 9 of Makers Academy, so we've been coding for about 3 months before building this. There was a team of 4 of us. I will link to their GitHubs below, as well as my own, and to the GitHub of this project. So we were building a blockchain. We wanted to task ourselves in 1 week to firstly learn what is a blockchain and then to actually build one. So I'm going to start off with the demo. Here is our website. So first of all, we're going to do a new transaction. We can call it from anyone you want. This is just simply a string. So I can go from Robert, and a recipient can be Jamie. The amount is due to something like 200. Great. Now we can see this appears in the pending transactions. We can build several of them up, but for demonstration we'll just keep it to 1. And then we can click mine, and that will mine the last one for us. And there we go. And we can see the chain on the right is updated. You can see we got our primary initial block, which you have to have for every chain. And then this is the one we just did. So this is, you see, recipient Jamie from Robert, amount 200. And here is the hash being carried across. And here's all the proof of work here. Okay, so building a blockchain. Once again, this was a week 9 project. We're going to be coding for several months, and it was done by 4 people: Jamie Lemertha, Suzanne Holt, Majdudeen Gibradi, and myself, Robert Clayton. Please find all the links below. Right, so what is a blockchain? Well, a block is simply a JSON file, or that's at least how we're storing it. And it contains 5 different things: an index, a timestamp, transactions, proof of work, and the previous hash. So the index is simply the position of the block within the chain. The timestamp is in Unix time, which is the amount of time that has elapsed since Thursday the 1st of January 1970, which is commonly used in computer programs like this because it's easy to compute and it's a simple number. So transactions require 3 parameters. We need a sender and we need a recipient. Simply strings. If it's something anonymous like a Bitcoin, it can be an ID, like in the example, or it can be something simpler. If it's a closed network, maybe it's a bank or something like that, it can be your actual name or a nickname or anything you want. The 3rd parameter is for data. Now we have the amount, as you can see, because we're doing a finance transaction. But if this was a voting application, it could be to register your vote. Or if it's maybe some sort of contract exchange system, it would be a contract, or anything else that your imagination can think of. Right, the proof, or the proof of work, often called the nonce as well, depending on the application. And it's simply a counter. And it counts the number of times that the computer has attempted to find the correct hash, which I'll explain about later. And the last piece of data is the previous hash. And a block will always need to carry over the hash from the previous block. This is for verification purposes, and means the chain can be verified by checking all of the previous hashes in the chain. And I'll explain more about that later. So, what are these hash things you keep talking about? Well, hashes are quite important. The whole blockchain is built on hashes. So, a hash is the value returned after using a hashing algorithm on a string. A hashing algorithm takes the string of any size and maps it to a string of a fixed length. So it's a way to encrypt data, and it is only one way, meaning that you can't find out the input or the original string from the outputted hash. So that's why password systems use this because you can never find out the original password from the encrypted result. You have to put the correct password in to get into where you want. So each time the same string is entered, you'll get the same outputted hash. And to check if the hash is correct, you would need to pass in the same string as before to get the same hash result. So you're string in and string out. For example, down the bottom, you put in password and out will come this hash. So how does a blockchain work? So to create a new transaction, the sender, recipient, and data must be submitted to the blockchain, as we saw previously in the example. The request is then stored as a pending transaction, and then a miner will take a collection of pending transactions and check their validity. If a block passes the validation checks, it will be added as a new block in the chain. And we saw all this from the demo at the very beginning. So, what is a miner and what is performing the validation checks? What validation checks does a miner carry out? Well, a miner is a single CPU on the network who volunteers to perform all of the validation checks. They will usually be rewarded for this. So how does the miner determine if a block is valid? There is an inbuilt difficulty level in the blockchain. This determines how many zeros need to be at the beginning of the hash, which you can see if you go back to the demo. We have 2 because we set the difficulty level very low because it's more of a proof of concept than we're wanting to wait half an hour for a block to be mined. And one of the miner's roles is to find this hash. So as you can imagine, the more zeros there are, exponentially it goes up with how complex the hash has to be, or how hard the computer has to search for it. So this is done by finding the new proof of work. So as mentioned before, this is a counter, and is found by adding the previous hash to the proof of work and hashing the result. So, for example, if we look at this example on the right, we see the first block in index 1. We see that hash at the bottom. So we take that hash and we would add 0 to the end. And we would push that through a hashing algorithm. And if at the end we have 2 zeros at the beginning, then we would have it. Then that's our result, and we'd add it to the next block in the chain. If it doesn't happen, then we add 1 to the end. So the previous hash plus 1. If that doesn't happen, previous hash plus 2, plus 3, plus 4. And as you can see, if you look at the index here of number 2, you can see that the nonce is 53. So we basically took the previous hash and added 53 at the end, added that as one big string, and out comes the other end. So you can see the hash there with 2 zeros at the beginning. And this becomes increasingly harder to find the more zeros we have. So other validations. So checking all the previous blocks in the chain and making sure the hash is correct when hashing the previous hash and previous work. So as before, we said we put the proof of work with the hash and out comes the next block. You can then do this for every block in the chain and check it's all correct and hasn't been manipulated or changed. And then the second thing they do is they check that they have the latest version of the chain. So this is done by searching all the connected nodes, so all the nodes in the network, all the other chains or versions of the chain, and they check to see who has the longest blockchain. And this is the longest in terms of proof of work. This isn't the how many blocks. This is the nonces. This is who has the most CPU power invested. So what makes a blockchain secure? Well, firstly is the validation checks, as we just described. The second is to edit or corrupt the chain, you would need 50% of the CPU of the entire network. The majority of the network has to agree on the longest chain. So when you search the nodes, as I just said, you find the longest one. 50% of the network has to agree its longest to be the current one. So in order to edit it, you need more than 50% of the CPU using it. So something like Bitcoin, no one in the world has 50% of the CPU of the entire Bitcoin, which makes it incredibly hard to overpower or hack. No country, no single company has that amount of CPU power. Another point is, to manipulate the chain, you have to redo all of the previous proofs from the point of manipulation. So if you want to go back and you want to change that money doesn't come to that person, but it goes to this person instead, you need to edit it at that point, and then you don't then need to redo the proofs, because remember, it's one way. The hashing algorithm is one way. So in order to get back up to the top, you then need to redo all of the previous proof of work, which takes a long time. And then, obviously, since that point, it would have progressed further and more transactions would have took place. So then you need to also do that and surpass that previous chain, which is incredibly difficult. And also, it costs an awful lot of CPU. And that's time they could have been spent, miners spent, earning money. And this comes into the last point. The cost of this process is very high. A miner benefits more from being an honest node and getting the benefits from that mining, getting those rewards, than trying to manipulate the system. So after we completed this project and we had our blockchain working, what was the next step? Well, something like Bitcoin uses this middle option, this B, uses a decentralized network, which obviously makes it extra secure. And this is the nodes on the network. This is everyone having a copy of the ledger, which means something centralized, something like a news network or a big website, big company has a centralized network. Their website is in one place. If you want to go look at the news, you go to their website, you go into their network and have a look and come back out. A decentralized network is completely the opposite. Everyone has their own version, and everyone's connected to, not everyone, but different places, and you find each other through that sort of network, which is what something like Bitcoin does. They each have their own copy of the blockchain, and that information is shared and you check these validation checks. You check who has the longest one, and you do all these previous validation checks as described before to work it out. And then the option C is the distributed network. So when companies get very big, like Facebook or something of that size, having one centralized network just doesn't cut it. You can't have that level of servers and everything like that in one place, and they need to have distributed. So they need to have a big sort of server in different parts of America, like East Coast, West Coast. They need to have one in London for all their users, etc., etc. So distributed is sort of the advanced version of a centralized network. But the decentralized, everyone has a copy. Everyone, has a copy of the server. Which means if someone like China, they want to block Facebook coming in. It's very simple. You just block all the Facebook servers. But for something like a Bitcoin or a blockchain, they can't. They can block one of the servers, or block one person. But as it lives on everyone's computer, it's impossible to take down because it's always replicated and you can always connect from a different place. So other things that might be nice to do, might implement a full payment system. At the moment we just have the blockchain as a concept, understanding it, and it might be nice to turn it into a full payment system. Another idea is a voting application, and I think it'd also be fun to do some mine races, so who can mine the Bitcoin, or who can mine the fastest. Thank you very much.